Good morning, guys. Today we're going to take a look at page 11 of the Unit 5 Classwork packet. Now, this page, what we're going to do is we're going to give you guys an overview of the 5 different ways that you can use in order to prove two triangles congruent, or to say, in simple terms, that two triangles are the same. And then in future videos, we're actually going to see how to do two-column proofs involving those, okay? But for right now, all we're really doing on this page is we're focusing on associating the name of the theorem with what it looks like in practice. In other words, what do the tick marks actually look like on the diagram? So let's start off with the easy one. Let's start off with SSS, which stands for side, side, side. If you have two triangles that are congruent by SSS, what that means is all 3 sides of one are the same as the corresponding 3 sides of the other one. That means that in a diagram, I would have this. I would actually have to have 3 sets of tick marks all along the sides. For SAS, or SAS, as some people like to think of it, notice where is the A? The letter A lies in between the 2 S's, right? So what that means then is that the angle that I know of one that's the same as the angle of the other is actually going to be in between 2 sides. Notice here how if I just put my finger on this and I read what I have, side, angle, side, the angle is actually included in between. Hence why in the statement SAS, the A comes between the 2 S's. For angle, side, angle, the situation is actually reversed in a sense, right? Because in that case, the letter S is in between 2 A's. So for that, here's what I would have. 2 angles and a side that's in between, right? So if I were to actually read out the information in order that I have, angle, followed by a side, followed by an angle, and that proves that those 2 triangles are the same. Angle, angle, side, as its name implies, would have 2 angles and then the side. For example, here are 2 angles, but instead of having the side in between, my side is actually afterward. Or it could have been before, but it just can't be, in between. Last but not least, HL. This one only applies to right triangles, because only right triangles have a hypotenuse. And here's what HL says, okay? HL says that if I have a right triangle, and I know that the hypotenuses, that sounds kind of weird, right? If I know the hypotenuse of each one is the same, and I know that a leg is also the same, I can therefore say that I have congruent triangles by hypotenuse leg. All right? Now, in the next couple of videos, we're going to see how you can prove 2 triangles congruent, okay, in the context of a 2-column proof. These are the 5 theorems that you're going to be using, but be warned, you are not necessarily going to be able to do it right off the bat. You may have to use some helper theorems and helper properties from previous units. For example, you may have to use vertical angles. You may have to use the fact that a midpoint splits a side into 2 equal parts. You may have to use the fact that an angle bisector splits an angle into 2 equal parts. You may even have to use 2 parallel lines cut through by a transversal and the type of angles that they make, okay? So just buckle up. It's going to be a lot, but at the same time, if you guys know these diagrams, okay, and if you can remember that the order of the letters in the names matters, for example, AAS, ASA, SAS, I think you're going to be just fine with all of this.